The light bulb is as follows. 7 participants are in a room that is slowly filling with water. Adjacent to the main room, there is another smaller room which is sealed off from the main room by a door which can be opened and closed by the participants. The goal of the game is to figure out which of the 3 switches turns on the light bulb. The game also has a set of rules to it. Rule number 1, only one switch among A, B, and C will turn on the light bulb. Rule number 2, the participants only have one chance to flip a switch while the door is open. If the door is closed, they can flip the switches as many times as they like. And rule number 3, if someone is in the room or if a switch has been turned on, the door will be locked in place and cannot move. Thus, if someone enters the room, they will not be able to shut the door and spy on the bulb while another participant flips a switch. Additionally, the participants only have one chance to answer as a group. If they answer correctly as to which switch turns on the bulb, they clear the game. However, if the water level rises and reaches the electrical wires before they figure out the correct switch, they lose. A potential fate which absolutely shocks one of the contestants. So what are the secrets to this game? What does it teach us?
If we look at it in the terms of probability, and probability is the concept of likelihood or unlikelihood of an event occurring, we can actually sort of see what the best possible solution is.
To the light bulb game, we see Tata suggest an ill-advised strategy for determining the correct switch.
とりあえずドアを開けたまま A のスイッチを押せば
それでつかんかったらどうするん？
でも電球がつけば A つかなきゃ B か C 50% までは絞れるでしょ。
He thinks they should just use up their one switch flip allowed with the door open, and then just take a shot and guess between the 2 remaining switches as to which one turns the light on. After all, as he says, they have a 50% chance of success this way. Since he's not good at puzzle games, and perhaps not very good at math either, he suggests a strategy that doesn't represent the group's best strategy for beating the game.
For calculating probability, what we look at is the outcome that we are testing, so outcome of success or failure, depending on how you want to look at it, and we divide that by the potential amount of outcomes. So if we look at it on a probability tree, which is simply a tree that we can use to look at all potential solutions, we can see that if you make a guess, you have 3 possible solutions, so you have a 1 in 3 chance of guessing correctly. Now, obviously, you want to increase your chances, and one of the other contestants makes a point of saying, well, why don't we just turn the switch on?
Executive member Anne Razuna then interjects to point out that the chances of succeeding using Tata's plan are actually 66%. Which is true, of course, because while yes, there is a 50% chance of correctly guessing the switch that turns the light bulb on after eliminating one of the 3 choices by using the one flip allowed with the door open, this does not take into account the fact that there is a 33% chance of choosing the correct switch on the flip with the door open.
Now, if you look at our tree, you can see that, let's say, for example, the solution was B. Let's say the switch that turns it on is B. Well, there are 4 out of the 6 pathways that will reach us to that possible answer. So if we select A first, it's incorrect, and then we say B, that would be a correct choice. If we turn B on first, that would obviously be the correct solution. And then if we selected C first, and then that was incorrect and chose to say B, that would also be a pathway that we can use. So there's 4 pathways that would give us the correct answer. So 4 divided by 6 multiplied by 100 is in fact 66.6 recurring percent. So she's right in that sense. So you might look at it and go, well, this is the best chance we have, and it's better than 1/3, it's even better than 50-50. 66 out of 100 times we're going to get it right, theoretically, so you know that's not so bad. And of course, she says that it's hot, so they know that the answer is A. But he actually gave himself a 100% chance of getting it correct.
Solution is as follows. Close the door, then flip one of the switches, say A, and then wait for a bit so that if the light bulb is on, it has time to get hot. Then turn the switch off, open the door, and flip another switch, say B. If it lights up, then you know the correct switch is B. If it doesn't, then have someone enter the adjacent room and touch the bulb.
Because by doing that, let's say for example, he opens the door, turns on B, it's off, she goes and she touches the light bulb, it's still cold, nothing happened, then you know that the answer is C, because the light bulb should have created some sort of heat, especially an old school light bulb like one of those. You can see that when we have 3 guesses and we try and find a pathway that has a guess as A, a guess as B, and a guess as C, every single pathway will give us that. So that is in fact 6 out of 6, which is of course 100%.
If it's hot, then that means that switch A is the correct choice. If it's not hot, then by process of elimination, the correct switch must be the only one that remains to be flipped, in this case, C. And this solution allows for a 100% chance of success.